again, those of you that are listening to this on video, this number 3, I forgot to change on your worksheet. Your number 3 is actually 3 we just did on the warm-ups, and you can print those out on the notes that I've uploaded to my website. Okay, so here's the answer to number 3 on your homework. Any questions about 1, 2, and 4, though? Yes, ma'am.
Number 4, how is the cube root of 8 negative 2?
Okay, the cube root of 8 is actually positive 2, but when we set this equal to 0 and move the 8 over, it's the cube root of negative 8. So you're asking yourself, what number can I multiply times itself 3 times and end up with a negative 8? And that's going to be negative 2, because negative 2 times negative 2 times negative 2 is negative 8. Whenever we have an odd number of negatives, our product is negative. Okay, good question. Any others? No? All right, let's move on. Okay, now, what I have on here, this looks a little different than yours because I only wrote extreme on yours. I didn't actually divide it up into max and min because I wanted you to tell me relative max, relative min, absolute max. Remember we talked about how a relative maximum of a function is the y value there, but I want you to write it like I did in red as the ordered pair this year. The relative max occurs at the point negative 3, 5. The relative max of the function is just the 5 part, but right now we're going to write it as an ordered pair. So take a look at 1 and 2 and see if you have any questions. Yes, sir.
Like on the quiz, do we only have to write the relative maximum?
I would like you to identify it as an absolute or a relative.
Okay.
What was the other word we talked about on Friday? What other word meant relative? I'm sorry.
It's on the tip of my tongue.
It's not on the tip of my tongue.
It's
But I'm going to look at my notes because I took them. And I can't find them.
Do you see the word local on your notes anywhere?
I do not.
Local.
Ryan,
You don't remember
It's
that?
not on my notes.
Okay.
Silly that.
I generally use the word relative, but it also can be referred to as a local maximum. Okay, let's take a look at the rest. Yeah.
For the zeros, do you just want us to do an educated guess, or do you want us to find your top?
When they're like this one, I would just do an educated guess.
Okay.
Very good question. Michaela?
What's the difference between relative and absolute?
Relative would be like this point right here. This is a relative min because in comparison to the points around it, it's the lowest point right here. But this point here is an absolute minimum. It is the lowest point on the entire graph. So this would be an absolute min, and this here would be a relative min. I did record the lesson on Friday, so you may.
I will go and look at
Good.
it. I'll try.
Good.
My computer's working. Can I look it up on a computer at the school? Will it let me do it on that?
You won't have enough time.
You can't go.
No. What? Wait, does it block us from YouTube still?
Yeah.
Yeah.
Just check out your telephone.
I'll look it up on my iPad. Check it out.
That'll work.
Or just use your phone.
Search it up.
He's a lame-o.
He's called.
Don't do that.
I call him a lame-o.
I know you did. And I told you not to do that.
Gotcha.
So
That's
what's
not
the
nice.
absolute min?
Huh?
So what's the absolute min again? I'm sorry.
This is the absolute min.
Okay.
The absolute minimum value of this function is 4. Or you could say the absolute min occurs at the point 1, 2, 3, negative 4.
Okay. What's the difference between the absolute and relative?
Okay? The relative is lower than the points around it,
Okay.
but not the lowest point on the graph.
I get you.
The absolute is the points on the graph.
Okay.
Okay? So this is an absolute max.
Okay.
Any questions? Okay. On Friday, for those of you that were here, we took a quiz. Those of you that weren't here from it because it's only a 5-point quiz. But let's go over these. Which of the following is not a function? It would be C, because 2 is paired with 1 and 2 is paired with 7. Number 2, which mapping shows the relation that is a function? It's A, because each input is only paired with 1 output, versus on B, 4 is paired with 6 and 8. Number 3, which equation shows the relationship between the x and y? So this is, they gave us the rule. Which one of these is the rule that represents this relationship? And it would be A, y equals 5 times x. Number 3 asks for the domain of this, which would be from -4 to +2. So it would be A. In an interval notation, this is inequality because I want you to see both. EOCT will probably have this form. My test should have that form. Number 5, what is the range of the relation above, bottom to top? So it would be from -3 to 3. Any questions for those of you that took the quiz on Friday? I think I entered those grades on Friday before I left. Did y'all see them? Okay, good. Okay. This is the graph that we're going to use for our notes today, so I'm going to give you a moment to copy that down, and then we'll go over it.
Can I give me some graph paper?
You don't need graph paper, just do a sketch.
Can you give me some notebook paper? I need a ruler. Should have thought about that when
I didn't want to get zeros. I kind of got
Yeah, I can.
I thought I got it right, but then I mean, zeros were like so that was right, but then what about the y? Are you really not y? I'm so dumb. Oh, that's why I'm doing so good. All right, thank you. Well, I'm so good. Oh, so that's I said done. So dumb. Right, I mean, all right, okay.
That's weird.
It's you guys.
So, okay, I guess you're not helping out. Baby. So what we're going to do today is we're going to look at the intervals where a function is either increasing, decreasing, or where it might remain constant. So the value of the function, where does it increase, decrease, or where does it remain constant? And when we do this, we're going to look left to right, and we're going to write it in interval notation, which is going to be our least x value to our greatest x value. All right. So what I've done here, down here at the bottom, is I've drawn in an x-axis. And because this graph goes forever this direction, it goes to negative infinity, and it goes forever that direction, it goes to positive infinity. When we think about this, I would like us to think about Dude Man riding the function roller coaster. There he is in his little car. He's about to go for a ride.
What's that on his head?
That's hair. All right, haircut. Okay. So, we'll always go left to right, so we start on the left. Here we go. We're on the coaster. Click, 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 click. What's he doing?
Rising.
He's going up, isn't
Wait.
he?
That roller coaster
Okay.
isn't going to be.
Must be
very
hot
good.
because he's riding.
Yeah.
No, it's not.
It's
So,
gonna be
the
painful.
first thing he does is he increases, doesn't
Yeah,
he?
it's not going to go back up.
He increases. And he increases until we get to this point right here, doesn't he? Okay, so this point right here is the same as what on our x-axis?
0.
0. So from negative infinity to, should have written that on the top, 0, dude man is increasing.
Oh, I thought
Okay.
you meant, like the
But-
points.
I'm just gonna get a new piece of paper.
No.
No.
All the way up to where there's a change. All right, now here, we're no longer increasing, are we? This would be like when you get to the top of the hill and you do that little curve on the roller coaster
Yeah.
right before it
Like
drops.
a mind bender?
Yes, exactly. All right, so right here, we're not increasing or decreasing, are we? What would we call this? A constant interval. So between 0 and 2, the y value remains constant. That is a constant interval. And then the fun begins. This is where we hit that first big hill, and we go shoo,
And then you walk
down, don't we?
So,
So-
that hill because you don't have
yeah, you go up a little.
This
bit,
is
and then
decreasing.
just go back down.
And then, because this is a function roller coaster, it doesn't really work like the ones at Six Flags.
Oh.
So then we're going up, 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 up forever.
Yeah.
How would it be good? How would he eat?
Why don't we start on the other end and go down? 'Cause when it sounds
Um,
like the
He has a
better.
point.
Just like we read, it would, but just like we read left to right, we do interval notation for
I
increasing,
just don't like the
decreasing.
fact that this roller coaster is really warm. These passengers are going to be really sad.
All right, so in here we describe intervals using interval notation. We're going to have increasing intervals, decreasing intervals, and constant intervals for this problem. For a lot of our functions, we don't have a constant interval, an interval where it's flat. None of our polynomials do. Our absolute value doesn't. Quadratics don't. Cubics don't. So we don't see the constant interval a whole lot in basic algebraic functions, but you can in lots of real-world application. But let's look at this. So we're increasing on this first interval. Well, it increases from negative infinity to 0. So that's what we would write. Our first increasing interval is from negative infinity to 0. And then what happened from 0 to 2? It was constant. So we have a constant interval from 0 to 2. And then what happened from 2 to 3? It was decreasing. And then from 3 to infinity, it was increasing. So I'm going to have to union that with what we already had, because we already had an increasing interval. Okay, those of you that zoned out, zone back in for a second. Thank you. All right, so we have the increasing interval from negative infinity to 0 and another from 3 to infinity, a decreasing interval from 2 to 3, and a constant interval from 0 to 2. Now, this is interval notation. It is not a point. Looks like a point if we just glanced at it, doesn't it? But this means over the interval from 0 to 2. Another way I could write this is like that. This function is constant from where x equals 0 to x equals 2. Now, I'm very particular on domain and range about when you use parentheses and when you use brackets, because there's an absolute right and an absolute wrong. But with these, there is some intellectual debate over what's accepted. I will only use parentheses, because when I think about this point right here, that point right there, I think about the 3 as neither increasing or decreasing. It's just where something changed. So I don't include the 3. There are other teachers that feel very strongly the other way, that we should include it. And there are some textbooks that back me up, and there are some textbooks that back them up. So this is one of those where you're lucky, because if you put a bracket, it's not wrong. I'm not as happy, but it's not wrong, so I won't mark it wrong. I will only use parentheses here. But I have seen it many times, and I've had some discussion with other math teachers about why do you do it that way? Why do you feel that way's right? Some people like that because they like good, healthy discussion, and some people just like to yell.
What teacher likes to yell?
I'm not telling.
Oh.
Wait, is there a teacher at the school?
Actually, no. Here, I like to have good intellectual discussion. And sometimes I'll say things just to be the, never mind.
Instigator then.
No, not an instigator. I just like to think
That's me.
both sides. Yes, Ryan. You had your hand raised a moment ago.
I'm
You settled it?
yeah.
Okay, excellent. All right, let's look back at last night's homework. And we're going to do, on last night's homework, we're going to now think of it as intervals of increase, decrease, or where the function remains constant. Now, those points where things change, aren't they our extrema? So what you want to do first is take your little x-axis down here and go, all right, what's my x value at the extrema? Looks like I've got one over here at -3. Looks like I've got another relative min right here at 0. And you're going to think about it this way. All right, what's happening between -infinity and -3? Here's Dude Man on the ride. What's he doing?
Dude, man.
He's increasing. And then what happens to get us from here to here? What do we have to do? Decrease. And then what happens here? We increase. So on this one, we have an increasing interval from -infinity to -3, union with from 3 to infinity. And then we have a decreasing interval from -3 to 0. So we're describing what's happening to the y using the x. Make sense?
Yep.
All right, next one. Oh, we only have one extrema, right? Right here at 0. So what happens from -infinity to 0? Increasing. And what happens from 0 to infinity? Decreasing. So we have an increasing interval from -infinity to 0 and a decreasing interval from 0 to infinity. All right, you try 3 and 4.
Alright.
On number 4, what's that point at
We called these -4.5, positive 1.5, and positive 2.5 earlier. Yes,
On the one
Andrew.
before, does it matter which way the arrows are going? Like, so does that mean
No.
positive? It's got a
Nope.
okay.
The function is positive up here, but
What?
I'm good. What was the include the word? This one.
okay. So let's take a look. This first one decreases from negative infinity to negative 2 and from 0 to 3. It increases from negative 2 to 0. Union with from 3 to infinity.
Yay.
Great. All right, this one. There's no infinity, is there?
No.
No. So it has an increasing interval from negative 4.5 to, I left one out, didn't I?
Negative 3.5.
Negative 2.5?
Count. You learn that on the school.
Okay, to negative 2.5. And then it decreases from negative 2.5
So 1.5.
to 1.5. And then it increases again from 1.5 to 2.5. How'd you do?
100.
All right, the front side of this, because it's hole punched incorrectly, the front is your homework tonight, which is awesome because it asks you for everything, doesn't it? Domain, range, 0,